So now I am going to derive an expression for atomic polarizability in terms of atomic radii. So for example, an atom of radius r is placed here, and no electric field will be applied, right? So that means this is the positive charge, this is the nucleus having charge plus Ze, right? And negative charge is uniformly distributed over it, and overall both the positive and negative centers will coincide. Both positive and negative centers coincide. Suppose electric field is applied along that axis, means along this direction. Say along this direction electric field is applied. So when electric field is applied along this direction, then what will happen? Say it is the initial situation. So what will happen? There is a separation between positive and negative charges. Means this positive charge, due to the application of this charge, it moves along the direction and it moves in the opposite direction, negative charge. So, and say R will be the separation between these two charges. So that means this cloud will shift towards here, and along negative it moves in this way, like this. And this is the separation between these two, and say this is the radius of this. This is the radius of this, right? This is the small. So that means, and this is the direction of applied field, means field is applied along this direction. Here this is the center of positive charge, and this is the center of negative charge. So what will happen? So when the field is applied, so this applied field exert force over the nucleus. So that means force over the nucleus will be, let us call that as F prime, and this force is Ze E naught. This is the force exerted by E naught over the nucleus, and because of this it moves a small distance apart, right? And another thing is that this force is balanced by this electrostatic field, means this negative charge means electric field at the nucleus due to negative charge, means this force is balanced by electric field at the nucleus due to negative charge. And this negative charge is induced over this because of the applied field. So these both the forces will balance each other, right? So this is the key idea behind the derivation of this one. So let us try to derive it now. So consider an atom. Sorry, we have to keep this diagram in mind. So let me so let us try to let me do one thing. Yeah, let me go to the next page. So consider an atom placed in electric field E naught, and due to this P is the dipole moment induced in the atom, and let Z is atomic number of atom as I discussed in the diagram. So thus positive charge on the nucleus is plus Ze, and let R be the radius of sphere, and atom is supposed to be spherical. With radius R. And now the applied electric field causes separation of positive and negative charge. And this separation, this is a very important key point. This separation continues till the forces on either of them, that is positive or negative charge, due to external field is completely balanced by internal forces. And let R be the separation between the charges when balance or equilibrium is attained. When balance or equilibrium is attained after the application of electric field, right? So now the magnitude of Now the magnitude of induced dipole moment is P is equal to ZER. So let us now calculate charge within a sphere of radius r, right? Let me go back to the diagram again. So here, this is the sphere about which I am talking about. This is the sphere of radius r, because this is the separation between positive and negative charge, right? So it is negative r. So I want to find out that how much charge is over this sphere. So let me go back to again here. So let rho is volume charge density, it's a volume charge density, and r with the radius. So that means this volume charge density is basically charge on electron cloud of atom divided by volume of atom, and this is nothing but this is minus z. It is the charge over the electron cloud, and its volume will be 4 pi by 3 r cube. This is the volume of it. Now charge within a sphere of radius small r, it is basically volume charge density multiplied by volume of sphere of radius small r. So that means this is equal to rho multiplied by 4 pi by 3 r cube. What is its value? Its value will be minus ze over 4 pi by 3 r cube and 4 pi by 3 r cube. This 4 pi by 3 will cancel out with it. So that means the charge comes out to be 4 pi it's minus ze r cube over r cube. That's what we are getting. Now the electric field, at the nucleus due to negative charge, it is equal to E, and it is minus ze r cube over capital R cube, and it is 1 over 4 pi epsilon naught r square. This is using the formula that q over 4 pi epsilon naught r square. I have used it, and this is the q which we are using. So right, so this is equivalent to this one. So this, upon slight modification, this will become, because this r square will cancel out with it, so it is ZER over 4 pi epsilon naught r cube with negative sign. Now the total force on the nucleus the nucleus due to negatively charged sphere. Say this F is equal to ZeE, because this is the charge over the nucleus and this is the electric field at the nucleus, right? So that means it is minus ZE R over 4 pi epsilon naught R cube into ZE, right? But now the total force on the nucleus due to external field is, that is E, external field E naught, it is F prime and it is ZE E naught. But these both forces will balance each other. But these forces balance each other, as I have discussed in the beginning. So that means F plus F prime, it must be equal to 0, and let us put their values. So it is minus ZE R over 4 pi epsilon naught R cube into ZE plus ZE E naught, it must be equal to 0. So that means ZE E naught, it is equal to minus, this will become positives, so it is ZE R over 4 pi epsilon naught R cube into ZE. This ZE will cancel out with it. So E naught can be written as, this E naught is equal to ZE R over 4 pi epsilon naught R cube. But as I know that ZE R is the dipole moment, so it can be written as P over 4 pi epsilon naught R cube. So that means this P is equal to 4 pi epsilon naught R cube into E naught, right? And if I compare it with that P is equal to alpha E naught, so that means this is sitting in place of alpha. So that means this alpha can be written as, means alpha means atomic polarizability, it is 4 pi epsilon naught R cube. So this is the expression for atomic polarizability in terms of atomic radii. So that's all for this lecture.